work at Google Cloud as a developer for a file system for cloud that was distributed. And then I decided to take a plunge into crypto by doing investments last year, mostly in Ethereum and Bitcoin. And then I realized the technology behind Ethereum, the blockchain itself, was very fascinating. So I started studying that, started building applications on my own, and decided to basically just quit my job and join with my friends at BToken. I was a co-founder and lead engineer there. So BToken is a crypto startup or an ICO company focused on decentralizing the home sharing industry. Think of an Airbnb without decentralized entity. I'll go a little bit over that as well. And then earlier this year, I founded Lumeos as a data sharing, decentralized data sharing and a survey platform on top of the EOS blockchain. So I had like a good experience in different multiple blockchains. I'll go a little bit over those in a bit. So
who's your co-founder?
John Zhao, was an Uber engineer.
I've met some of your people. BToken is a big deal. I mean, everybody talks about that. I've had people walk in my office say, we want to imitate what BToken is doing.
Yeah, so I mean, we've done like really well. We raised $50 million in funds, and we have a really good team. And the idea was basically to build a decentralized way for doing payments between hosting guests, keeping track of reputation in a trustless system so that the host and guests can trust each other, and have an arbitration system where users can vote for whether a user, like whether a host was good or not good, without having a centralized entity. So doing all this in a decentralized, trustless fashion was a really good project. And it's still going. I mean, the idea is to now to just get to marketplaces, and yeah. So
used it.
What's that?
I've used it.
Really nice.
I lost on BToken.
Okay. Awesome.
Cool.
Yeah, we're and I think it was San Francisco and LA. We've been like expanding further into other places as well.
Airbnb investing in you?
No. I think we've met a few PMs from Airbnb. But,
Probably an improper question, sorry.
yeah. So I mean, so expanding in the U.S. was very difficult compared to expanding in like outside the U.S. mainly because of regulations. So whenever we talk about blockchain, I wanted to go over all these 4 topics. I think I'll just like fix on technology and economics, and maybe a little bit on business, but we'll see how time goes by. So starting with blockchain, I guess like Bitcoin was in 2008 was the first pretty much experiment on being able to send and receive money without a centralized entity like a central bank. So no third parties, money transmitting. And then Ethereum came along, I think in 2013, 2015 as a way of programming, basically adding a programming language on top of the blockchain to use the features of decentralization, but not only to send and receive money, but also to verify transactions between the code, what is called the smart contracts, on top of that. There's also IPFS in the last couple of years as an interplanetary file system, which is basically a decentralized file storage that nobody owns, but users can able to share data there. So imagine of decentralized S3 storage or decentralized cloud in a sense. And then EOS and other blockchains came later on to basically, like proof of work was a very successful yet very slow algorithm. Proof of stake came in to solve some of the problems, and then further systems like delegated proof of stake introduced concepts to ensure that the blockchain it runs in a lot faster way. So in order to reach scalable and fast systems, EOS was one of the leaders in that space, and the idea was to introduce some centralization, so it's not fully decentralized in a sense, but now you can scale to millions of users rather than hundreds of users in the previous blockchains. To give an example, for instance, one of the biggest application of Ethereum that was launched last year is CryptoKitties. I mean, if you've heard of that, and at some point it has like 500 daily active users, and that's it in comparison to like Facebook, which has millions and millions of users, or Visa, like that has a lot of transactions. And in order to do that, you need to make sure that the blockchain is scalable enough to handle that kind of load.
We're gonna do a case study on CryptoKitties later, by the way, and it'll be up to you to tell me why that is a good thing and why there really is value in those CryptoKitties, because they're worth, like, some are worth thousands, right?
Yeah. So yeah, blockchain technology is a new technology that is enabling pretty much Web 3.0. The concepts behind Web 3.0 are all about decentralization, meaning that there's no centralized entity, getting rid of monopolies so that no one has a big ownership. Rather, the value is shared between the participants of the network. And because of nobody owns it, that means you can create something called a private key, where you can actually own something on the network without anybody owning anything. And it's a weird way, but it's because of the trust factor, the privacy, and because of the latest issues with like GDPR and this like shift towards importance of privacy, felt like blockchain is going to be a central and like an important factor of Web 3.0 of the future, where users are owning of their information at the same time fully control their privacy.
So everyone know what GDPR is.
Probably everybody had to like check a box on privacy.
Can you describe what GDPR?
So Europe is, that's a data privacy regime in Europe. It's law. So if you have any individual consumer in Europe's data, you have to comply with their privacy rules over there. If you're a European person, for example, they have a right to be forgotten. That would be interesting to see how that works out on the blockchain. They have a right to have their information deleted. You can't share it with somebody unless they consent. It's a bunch of rules that European companies have. California's got its own GDPR coming next January 1, 2020, by the way, which is way worse than Europe. So we're gonna have that here in the United States.
Yeah, so here's just a quick breakdown of Web 2.0, which is what we have today. Web 2.0 is basically like Google, Facebook, Uber. In a sense, they is a centralized entity that you share information with, and basically delegate your information. They control it. They control the business logic. You control the data. They control the algorithms and all like the search in Google. And Web 3.0 is more of a decentralized. There's no centralized entity that can view the data. In a sense, you're in an environment where you can trust, where you don't have to trust anyone, but you can trust the collective. So trustless trust. It's tamper-proof because of blockchain. So also, the algorithms can be run through smart contracts that everybody can see, so that you're not surprised by what's happening with your information or what's happening with the transactions. Examples would be like esteemed and IPFS. And actual Everpedia. Everpedia is like a decentralized version of Wikipedia. So what is blockchain in a nutshell? It's basically a set of computers, distributed database. So people on using the blockchain or through Bitcoin or through other methods, they're doing transactions. And when those transactions have happened, they're broadcasted to a pending pool of transactions that need to be verified. And then there are verifiers that verifies the transaction, either the delegates in delegated proof of stake or the miners in a proof of work in a trustless fashion. That's what it's called, the consensus algorithm of every blockchain. And then after all those transactions are verified, they be put into a block, and then the blocks go into a chain over time. And basically the longest chain is the definition of a blockchain. There's multiple long chains. It's pretty much a fork. And, something happened in Ethereum at one point in 2016, I think. There's a DAO hack where Ethereum had to be forked completely because there was a lot of millions of dollars in ETH coin that was pretty much like stolen by hackers, and the Ethereum network had to go back in time pretty much and then verify a different transaction, a different fork, and then the longest chain became what is called Ethereum today, and the old one became Ethereum Classic.
How did they break into that? How did they?
They didn't have Ethereum, they had
Consensus.
DAO.
So what happened is everybody had to come and vote on it, like basically the miners of Ethereum, and say, okay, this is the longest chain now, and because of that, that became what it, like basically, like the blockchain is what you or what the miners want it to be.
Yeah, I see what you mean.
Let's pause on it. I wanna make sure everybody understands that. That's really interesting. with that DAO hack. So here's an application sitting on top of Ethereum that got hacked, okay? What was it, $50–60 million stolen. So, well, what are you gonna do? Well, if we could go back to Ethereum and if we could get the underlying blockchain to just not validate those transactions, they go away, and the bad guys, they don't get their $60 million. You know, we just give it back, you know, to the people who had it. So that's what they did. So they had to vote on it, because you need a consensus. And there's a really libertarian wing of Ethereum nodes that said, well, wait a minute, you know, a deal's a deal, rules are rules, we can't have people interfering here because, you know, camel's nose under the tent kind of thing, and we're changing all sorts of things they don't like. But then there's other people saying, well, look, we can stop this, the money was stolen, we should just fork it, so, you know, so we've got a legitimate set of transactions. It's interesting just because of that debate that took place within the Ethereum community.
And the best part is that the Ethereum foundation itself is not like really a centralized foundation in a sense that they just said we need to vote. They wouldn't be able to reverse that themselves. So that's the difference between, again, like a centralized entity and a decentralized space. Like you need the consensus of everyone else. So in a nutshell, these are the blockchain features. I guess like we reiterated on them, so I don't have to go. So technically speaking, what is blockchain? It's a growing set of Merkle trees. In the case of Bitcoin, it's pretty much hashes of the transactions. The transaction being you sending money to someone else, or you sending Bitcoin to someone else on the network. In the case of Ethereum, it's a hash of EVM state. EVM is the Ethereum virtual machine, which is what the state of that. So like I mentioned before, blockchain is a set of computers. Ethereum is a program running on that computers. And then the state of that program is what is being verified, the transactions that are happening between that. And I'll go into more details in a bit. I guess in order to understand blockchain, I usually go with hashes and then Merkle trees and then blockchains. So first off, hashes is pretty simple. You create a function, you hash A, you get a value B. If you change anything, any small thing, the full hash becomes something completely different. So it's always one way, and if you do any changes, it cannot go undetected. So now that we know what hashes is, take a look at what Merkle trees are. Merkle trees are pretty much hashes of those hashes, whether it's the transactions or whether it's the state of the virtual machine. Again, like all the transactions get hashed, and then there becomes a root. If you change one thing, there's completely new root. And the best part is it's easy to prove, so you don't have to you just go onto one branch rather than going onto the entire network. So that's why if you want to download like an Ethereum client on your laptop, rather than downloading the entire blockchain, you can download a few nodes on the chain, and you will be able to reconstruct everything. So what are blockchains? Blockchains is basically a growing Merkle tree. It's like pretty much, for a software engineer, it's like a linked list of all those nodes of those trees. And it's pretty much a distributed immutable data structure that could always go further in time, and that helps against the double spending problem. So in case of Bitcoin, again, it's proof of work consensus, and it's those are the transactions that are happening over time. In case of Ethereum, it's the hashes of the virtual computer, the virtual state of the virtual computer state at that point in time. So the transaction pool, the pending pool state, is basically all the functions that are being called on Ethereum. So when you upload a smart contract onto the blockchain that says host A must put in that security deposit, and then guest A, who's going to host A, needs to put a security deposit, and then when time equal 3 days after the booking date, the money goes from the guest to the host. That's pretty much the function inside the smart contract. That's what it says. And the transactions that are happening when those functions are triggered goes to those transaction pools that get verified and then get put into the Merkle trees and go further in time in the future. So it's pretty much the programmable states via the smart contracts. So there's also a concept of gas in Ethereum. So when you want to call a function on a smart contract, you need to give it a certain amount of ether. Ether is the currency of Ethereum. And when you pay that gas fee, the fee goes to the miners of the Ethereum platform. So in case of Bitcoin, the Bitcoin is basically generated, minted, and then given to the miners. In case of Ethereum, Ether is also minted, but at the same time, people on the platform who are using it also pay fee gas that also goes to the miners who are powering the blockchain. So what is the blockchain consensus that we're talking about? So you have to have a set of rules that ensures that the content of the blocks are okay, and then the order of the blocks are okay. So that's like the consensus, and this is like what proof of work is, kind of consensus that ensures what goes into the blocks and the order of the blocks. Same thing with proof of stake, same thing with proof of authority and others. So in the permissionless blockchains, there's a concept of Sybil attacks might happen, and a Sybil attack is something that multiple people can actually join the network in order to gain basically full control over it, like 51%. And different consensus algorithms have to fight against that kind of Sybil attacks on a decentralized system. So in case of proof of work, the miners can do that. And so in case of proof of work, you have to mine by actually solving a very difficult problem. In proof of stake, you deposit to verify transactions. Delegated proof of stake, you vote for delegates who will verify the transactions for you. There are other different consensus as well. So in proof of work case, it mitigates the Sybil attack by ensuring that the validator have to solve a very difficult problem. That even if you get multiple people trying to basically take over the blockchain, won't be able to do it. Energy, you have to spend a lot of money, and at the same time, the energy cost is huge. Again, one of the actual drawbacks of proof of work is basically it's very bad for the environment. It's actually, in order to power Bitcoin, we're wasting a lot of energy.
Could you please reiterate what Sybil was? I think I missed that.
It's when multiple nodes try to take over the network. So for instance, in the case of blockchain, multiple miners will just jump into the game just so that they can take over mining the Bitcoin and verifying transactions that they want. So they're basically bad actors on the network that want to take control of it. And the fact that they cannot do it because they still have to solve the difficult problem. Even if they have the latest, so these ASICs chips that are usually used by Bitcoin miners are basically state-of-the-art hardware that can actually verify transactions on Bitcoin. You have to have a lot of those, and you have to pool with others in order to kind of take over the network. Some people still say that Bitcoin is pretty much centralized because there are 3 mining pools that own 70% of the entire mining production. But I guess that's one drawback of.
Maybe you have an exact number, but a rough estimate will do for me. How many miners are there?
So there's a lot, but usually what they do do mining pools where multiple miners will just you probably see those videos of full data centers of miners who are basic miners are computers that are just running the code, right?
Right.
And there's no real way to tell if someone did, or I guess if a group was getting close to 51%. Is there? How would you know? Let's say, I don't know, somebody or a group in China, for instance, is planning that takeover, right? Or is close to it.
Yeah, so you can see all the addresses, and you can always tell where the mining is happening.
Okay.
You can think you go blockchain.org. That's where you can take a look at all the blockchain, the Bitcoin transactions and the Bitcoin addresses. But yeah, it's difficult to actually tell about that. But the best part is Bitcoin holders will ensure that because you have Bitcoin, you want to make sure that the network is in a good shape. If you are a miner and you're making a lot of Bitcoin, you don't want Bitcoin to be jeopardized because you will start losing money. And it sounds like the cost of Bitcoin will go down if something like bad like that happens. So you're kind of incentivized to do the best for the network. So it's actually one of the good things of blockchain. Everybody pretty much gets incentivized to be part of it. Because you hold some part of the network, you're incentivized to be good on it.
Yeah, because I guess if someone took it all over, then essentially no one would really want it, right?
Yep.
The value would go to zero.
Pretty much. Because like for Bitcoin, like, and I have some slides on current cryptocurrencies, basically the value of the currency is determined by what you think the value of it is. Right now, people think that the value of Bitcoin is $6,000, and they're willing to pay $6,000 to get it. But again, like, this is pretty much, the cryptocurrency is not real. It's basically just a cryptographic key that you keep, and that's not what Bitcoin is.
Okay.
So proof of stake, again, basically you put a stake into the system and you verify the transactions. You're incentivized to be a good actor and do the right thing, because otherwise you lose your money that you staked. And because of that, again, because you have the incentives to act good, civil attacks are also mitigated by that. So delegated proof of stake is an interesting take on proof of stake, rather than having everyone on the network. So because one of the drawbacks of a proof of stake is it's very difficult to engage all the stake owners. But with a case of delegated proof of stake, the people who own the, let's say, the token or the currency of the blockchain, they will vote for the delegates for them, like 21 or 50 or 30 or whichever amount of amount of nodes that they want to do the verification. And those nodes will basically do the verification for you, and then they can incentivize with tokens as well. EOS is a delegated proof of stake blockchain, and the way it works is the holders of the token can stake their tokens and vote for block producers. Those are the 21 block producers. And those 21 block producers are incentivized by the inflation rate of EOS. So EOS started at 1 billion coin, and then it inflates at a rate of 5% every year. And part of those 5% goes to the block producers as an incentive for them to verify the transactions and to do the right thing. Bad block producers are pretty much voted out because the community can decide, okay, you're doing the wrong thing, I'll remove my vote. And voting is always continuous, so you have to continually vote, which is problematic because majority of people usually don't vote, and you need to get 15% to get anything done. So smart contracts. So Bitcoin, for instance, we mentioned it's not a Turing-complete language or blockchain in a sense. So Ethereum was the first of its kind. It uses the blockchain. It uses Bitcoin's idea of blockchains and proof of work and added the concept of smart contracts on it. So smart contracts was determined like in 1994, and it's not something that came with a blockchain. But the idea is you can put a set of rules into a contract without having a centralized entity, basically. So it can have a function between strangers on the internet. And it just happens. It ensures that files facilitate the transactions without the middleman, without a centralized entity, and it enables a new kind of applications to be built called dApps, or decentralized applications, where those decentralized applications interact with smart contracts that are running programs on top of a blockchain. So in case of Ethereum, for instance, a smart contract is a special kind of account. So today I can create an account on Bitcoin, and then I can, by basically having a private key and a public key, and then I can send money from that account to another account. In case of a smart contract account, it's an account that is initialized, that you can create it, but you don't give it a to field. A to field, like instead of sending to someone, you just like create the account, and now it's a smart contract on the platform. So now you can have multiple transactions. So when you create the account, when you create that account, you give it a payload data, and that data is the code, whether it's in bytecode, whether it's in Solidity, and that is transformed into bytecode or WebAssembly or whichever code. But basically, the transactions that happen within the blockchain are either like one account to one account calling a smart contract, one smart contract doing something to another account, or a smart contract talking to another smart contract. And that's what became like a pretty much an operating system where multiple smart contracts start talking to each other. And that's the concept of protocols on Ethereum. Yeah.
Can you give an example of smart contract talk to smart contract?
Yeah. So you create a. Let's see. You have a protocol. The concept of a protocol on top of Ethereum is basically a functionality, which is a smart contract that does one thing. So for instance, there's a protocol for reputation, and then there's a protocol for payment. So let's say the payment smart contract says, I will only pay this person if the reputation score is X amount. So the smart contract for payment will call the smart contract of reputation and ask, is this account reputable enough to do this transaction? We'll get back to the smart. So now the reputation calls the payment. And in a sense, as a developer, you need to make sure that each of the smart contracts have enough gas to do that on Ethereum, for instance. And that's like one good example. So I have some use cases as well on eToken and Lumeos, and I can discuss those if we have time. So that was the tech in like pretty much very quick nutshell, I guess. So I wanted to talk a little bit about cryptocurrencies and what is the difference between actual cryptocurrencies and money. So cryptocurrencies are a way for users on a blockchain to have a stake within the community and be able to do things like voting, like sending money and receiving money, like buying goods, and staking for verifying transactions. So compared to money, like the value created for tokens is based on demand, it's based on scarcity, uniqueness. So basically for Bitcoin is pretty much like what people call a store of value, because they think that Bitcoin will always go up. So you'd rather like use it, keep it, store it, rather than pay stuff with it. For others, it's a medium of exchange where you can buy goods and services by using the cryptocurrency, or you can just exchange different cryptocurrencies together. So in the case of ICOs, which is basically projects created on top of the blockchain, there's this concept of crypto economics where the token itself will have an economy behind it. So when you create so there's two different ways of creating coins, either minted or mined. In case of Bitcoin, it's mined. In case of like Ethereum, it's both actually minted and mined. In case of ICOs, it's usually they will create a fixed token supply. Let's say there's only 1 billion tokens, and the interactions between the users on the network is basically determines the economy of that token. And if you want to make sure that your token is healthy, you need to make sure you have a stake in the system, or you have voting, or you have a payment, or a purchase power, or voting power.
Could you describe the difference between minting and mining?
So minting is basically creating tokens from thin air, just like inflation, for instance, in the case of EOS, where you just like mint 5% of tokens every year. Mining is basically in case of proof of work, you have to approve something, like solve a mathematical problem, and for the 4 zeros, and then you will get the token mined and given to you. So minting enables funding through ICOs. For instance, like when you ICOs is basically initial coin offering, and it's a concept that was very big in 2017, not too much in 2018. But the idea is basically you say, send me Ether, and I'll give you X amount of tokens in return. And then when you run your ICO by running the smart contract, it will basically say this address gave this much Ethereum, and then this is how much we'll give them in our token that we just created on Ethereum. I guess I went over tokenomics. Tokenomics is basically the usage of the token. So these are some questions like pretty much if you want to create an ICO or you want to create a new coin on top of a blockchain, you need to make sure that your token that you created or you're minting has some features behind it. Otherwise, you don't really need the token. So a lot of projects like probably got launched in 2017 basically just created a token for the sake of it without like having, I think I have like 17 different points that you need to make sure to have when you create a coin. So you need to make sure to check most of these boxes, otherwise you really don't need a coin to run your new system, and you can just use the existing coin, or you can just not even use the coin in the first place.
Are you gonna share these slides?
Yeah, I have a link, it's public, I'll put it on SlideShare.
Great,
I'll distribute it.
thank you.
So from a business perspective, this is actually the one thing I wanted to discuss is, do you really need blockchain? Do you really need a token? And as an existing business or as a new business, these are some questions that you need to understand before like just jumping into blockchain. So think of the user base. So is there lack of trust between the users? Is there needed trust between the users? Do you want to exclude a third party or a middleman from the game? Do you want to make sure to have a high level of security, but at the same time you don't want to own users' information? Blockchain is good for you if you want to build a trusted system and a decentralized system without a middleman, and at the same time ensure high security of the platform. I have another completely topic, basically to choose which blockchain to build on, and probably we will discuss it today. So these are some few blockchain use cases that are definitely something you can consider blockchain for. For instance, IoT, registering connected devices. Data, for distributed storage, like IPFS. Identity is one of the biggest problems that blockchain is trying to solve today, and basically verifying individuals' identity. So today, on the blockchain, if you are using Bitcoin, maybe not today, maybe in 2015 or before, if you're using Bitcoin, you're using it either for drugs or for bad stuff, like Silk Road. And because nobody can know who you are. But now with exchanges today, what they do is they go through a KYC process, or know your customer, where you have to like upload your passport before you are able to liquidate your Bitcoin into dollars or other currencies. So today, like most of blockchains themselves are like, you don't have to know who the person are, it's just like an address on the network. But if you can add an identity layer on top of the blockchain, then every person have an identity. That's a very important use case. Proof of ownership, for instance, real estate, rather than having physical deeds, you can have your deed on a distributed ledger. Legal, you can have smart contracts to make legal transactions. Crowdfunding, ICOs, marketplaces, voting. Voting is one interesting aspect of blockchain. Most projects are incorporating it. Hopefully, a few governments are actually implementing voting via blockchain. Yeah.
For the IoT, do you have any examples, or can you share a little bit of like why two physical devices need to talk to each other, like how that works?
Yeah. So basically, one good example is I've been like advising a company that did IoT devices in this closed environment, and let's say we want to send this closed environment to space. That environment is itself would not be able to communicate with a centralized entity on Earth, for instance, and these devices need to be able to talk to each other without going through a central entity. So in a sense, like you can get the health of the devices and keep track of if the device is on or off, if its battery is in a bad shape, and all that, and then propagate that information onto the blockchain and then listen onto that. It's one use case. Other use case is just creating a distributed registry of all the devices that are inside a certain system, communicating to each other. I mean, in a sense, you can always do that in a database, but you want to make sure that the data is one, up to date, but also that nobody is modifying any of the information. So I think I mentioned a little bit about identity, but this is one of the really interesting case studies is being able to build identity. And I think Civic and Uport and some other companies are attempting to do that. But if you think of Twitter, one of the biggest problems of Twitter is fake accounts. And Twitter keeps on trying to like delete all those fake accounts. There's also this paradigm of having one user, one account. And it's also very difficult to implement in a centralized system. And the concept of verified users, where now that if you're verified on one blockchain and you want to use a different application on the same blockchain, you don't have to go through the same verification process. So it's going to like really be similar to a single sign-on process, where now I'm verified here and I don't have to do the entire verification process again. So BToken is another example of a decentralized application that we built on top of three major problems. So we didn't have to solve the identity problem because we used a third party that did the identity for us, but we wanted to solve the payment problem without a centralized entity, and then the reputation, and then the arbitration. So with Airbnb case, you just call customer service and tell them, hey, my host is not there. And if you want to try to build something similar in a decentralized way, you cannot do that. You need to ask people within the network, is anybody online? And these people will basically pretty much be arbiters who have put in a stake into the system. And if they don't answer within 24 hours, they'll lose their stake. So they're incentivized to answer within a certain amount of time. And they will go ahead and, like, let's say 5 people say, 3 people say host A is right, the guest A is wrong. No, and then the other 2 say the otherwise. The 3 people win, the 2 people lose, in a sense. And now we have decentralized arbitration, which is also one of the big problems of blockchains is really good at solving a judging system, basically. As for reputation, also, like if you're starting a new system, it's going to be difficult to say which guest is good, which guest is not good. You can take that information from Airbnb for sure, but then what we need to make sure is you have certain rules and thresholds based on the reputation level of a certain person on the blockchain. And so basically, if you have a, let's say, a reputation score of 70 out of 100, you can go ahead and book a place, but if you have less than that, you cannot book a place. So these kind of rules that come in. And you can do something to increase your reputation, maybe pay extra tokens, or pay more in your security deposit. So those rules are something that we built. And then the last case study was, so Lumeos is a system that we're building today for data ownership on the blockchain. So we took the concept of you own your private key, you own your cryptocurrency, and we extended it to you own your private key, you own your data. So it works by also hashing. So you get your information on your mobile phone, you hash it, you store it on the blockchain, you are the only one who can have access to it. If you want to give that access to someone, basically, you control your privacy and you want to give your information to somebody else, you can download your information and send it to them, or you can give them access to a key that they can use to decrypt your data on-chain. And you can also have rules around it where if you want to give your email address to a marketing agency, you can tell them, hey, you should pay me in tokens in order for me to give you that access. And then in a sense, the blockchain becomes a medium of exchange between keys and cryptocurrencies. And our idea is to extend that to pretty much all your behavioral information online, where you can sell that information to advertisers and start making money. So if you like start browsing for cars and start seeing advertisements about cars, you know for a fact that you actually made money. Basically, you got tokens because a company actually knew that you were browsing for cars. And if you don't want to share that data, you don't make anything, but now you're fully in control of your privacy.
I have a quick question. So, 2 significant companies in the Bay Area, their entire business model is on advertising. So this is wonderful, this idea. So, do you think they would be working on this, or I mean,
so
is this
Facebook
like,
has its own blockchain department right now. Google has been working on blockchain for a while as well. The idea is that again, like blockchain will just work in parallel with centralized companies, and centralized companies are pretty much embracing blockchains. Like IBM is one of the big, like IBM is doing blockchain,
Huge
Microsoft
blockchain,
is doing
yeah,
blockchain.
and Oracle too.
But and Google has been also working on something, and Facebook is actually very big right now. Like they actually did have a director of blockchain and a VP of blockchain. They're actually doing something that's secret that nobody knows right now.
But that really turns their business model on its head though.
Yeah, I mean that's the idea. The idea is that we rather than so if you use Facebook today extensively, you're basically missing, like Facebook makes $100 to $1,000 on you every year, basically just by using it. So imagine being able to use Facebook and actually getting a paycheck at the end of the month or at the end of the year saying, we used your this and this and this information, this is your cut out of it. And that's what like the idea of what we're doing at Lumeos.
That's kind of also what Brave does, right?
The browser.
Yep.
Yeah.
What does?
Brave, it's a web browser that basically blocks all the commercials that are not theirs, but when they show you something, you also get paid in a token called BAT, which is what the announcers pay to be announced, I guess.
Yeah, so that basically you see the advertisement and then you get paid for it.
Thank you.
Yeah, that was the last slide. Yeah, and I guess we can go for questions
A
now.
couple of questions?
Yeah.
Do you have any recommended reading where you learned all this stuff?
It's been interesting. Like stuff keeps